How are disaster management and supercomputing related? We'll find out next. Welcome to this panel discussion about a panel discussion that will be taking place at SC22 in November in Dallas. Would each of you please introduce yourself?
My name is Dieter Gansmüller. I'm a professor of computer science at the University of Munich, and I'm also the chairman of the board of directors of the Leibniz Supercomputing Center.
And I'm Dan Reed, professor of computational science at the University of Utah, currently also chair of the U.S. National Science Board, which oversees the U.S. National Science Foundation.
Well, how is your panel on disaster management capabilities in supercomputing centers particularly timely right now?
Dan, you want to go first?
Sure, I'll bite. I think, a couple of ways, and I'm mindful that as we're recording this, a major hurricane is striking Florida in the U.S., and there are major effects of that. I think as we think about disaster response in supercomputing, there's sort of two ways to look at it. One is how we actually use advanced computing to be able to predict and then mediate the effects of disasters. And all of us are aware of the contributions of high-performance computing to weather forecasting and storm track prediction and those effects. But it has a lot of other things that we don't often talk about. We want to understand the effects of storms on chemical spills and other issues where there might be other hazards produced by a storm. Computing can help with that. And of course, the other aspect of this is how do you keep your own supercomputer center running if you happen to be in a storm track, particularly when it is providing critical services related to forecasting and disaster response. And the panels really, I'm confident, will touch on both of those aspects.
This topic includes organizational and budgetary and technical challenges. Can you give us an idea of how these various impacts, how these impact each other?
Well, the point here is you in order to do this computation, you need to have the resources available at a particular point in time. And that's against our traditional batch-oriented usage model for the supercomputers. So in essence, we need to find methods to start the computation once it's time that we need some results or some insights on what's going on, what's happening. And that, of course, also has budgetary effects, because in the end, we cannot just reserve these valuable resources for a long time. We really need to find some computational ideas or technologies that help us to intersect and say, now we need this resource and now we do that. And that goes even into governance, because who would want to decide that we are now switching over to this particular point? Which organization, which institution would do that? Yeah. So there's a number of interesting problems which are even non-technical to solve here.
Dieter's absolutely right. I remember when Hurricane Katrina struck the U.S. and us madly draining the batch queues at NCSA because we wanted to shift to a higher priority task related to modeling that disaster. So there absolutely are organizational issues. I would say that one thing that I've seen, and as we think about another kind of disaster, how we collectively try to respond to COVID using computational modeling, that one of the things that really was surfaced there was the challenges of sharing information across organizational boundaries. Because many of these things require cross-disciplinary data fusion, and certainly in the case of something like weather forecasting, being able to do real-time data assimilation is a critical piece of doing accurate forecasting. So yeah, there are real organizational barriers sometimes to look, we don't have much time, we have to make a decision, we need to break down some barriers and do what's right as quickly as possible. And then there are all those organizational challenges that come with that, making sure the right people are in the loop, that one knows how to access data, even if permission has been given, and understand what the formats are, and then all the logistics issues that go with that. In the end, as important as the technical aspects are, and I can't overemphasize how important they are, the human and the organizational pieces often are the bureaucracy that prevents us from doing the right thing.
What are some strategies that you can use to mitigate these risks or to break down some of these organizational barriers?
Well, I'll throw out a couple. One, of course, is to actually try to do this when you don't have to do it on the fly. So that's why people do disaster response scenario planning, wargaming, as some people call it, where you actually bring the folks together with a hypothetical disaster and you talk through what would need to be done and expose problems so you can try to reduce them before you're in the throes of battle and really don't have much choice. So planning does help, and that's the way you try to expose some of the unexpected. It also means that you know whom you need to call in order to make something happen. Because if you're making acquaintances for the first time in the middle of a disaster, you're already behind the curve. You don't have the level of trust, you don't have the organizational commitments necessary to make things happen.
Yeah, I would agree to that. What Dan just said. I mean, the point is, one example was also the COVID thing. Yeah, how do you get the resource allocation in the first place? How do you make sure that you get all this compute time that you need? And that actually needed the experts to kind of check if that is a proposal that works. Where would it work? Which machine to put it on? These kinds of things. Yeah, it's exactly a combination of bringing all these things together. And these games that Dan was mentioning is really one way of trying out, does it work the way, where do we have deficits, where do we need to improve these kinds of things.
And I think COVID also exposed the other, and Dieter touched on it briefly, if you think about COVID, understanding which of those computational models were going to improve our long-term understanding.
How does an event like SC contribute to these war games or this planning to bring all these people from various disciplines together?
Well, in the first place, it's an opportunity to exchange ideas, and I'm sure that more people than just Dan, myself, and the others on the panel are thinking on this topic. So we really wanted the interaction with other people to hear about the experiences and to hear what they can contribute in similar situations. After all, these situations are really kind of affecting all of us worldwide in different kind of extreme situations, and we might just learn from each other, and that's what SC is for, at least in my opinion, in the first place.
I completely agree. I think, you know, we are all looking forward to the global community actually being back together post-COVID, and there are really only essentially two global events, one in Europe and one in the US, where the entire HPC community comes together, and SC is one of those.
If prospective attendees at SC are on the fence about attending this particular panel, why should they make it a priority?
Well, I'll connect it to something I said at the opening panel, plenary panel at last year's SC, which is I think it's really important for those of us in the HPC community to not just focus on the geekier aspects of the technology or the science. We are in the business of using technology to address societal issues. And this is front and center as we see climate change and severe weather and the effects of pandemics. These are front and center issues that affect all of our society. And we have an important role to play in that, both ethically, but also intellectually and scientifically.
Dan and Dieter, thanks so much for being with us today.